Hello class, in this video, we are going to learn about the subtopic extraction of metal from its ore. Okay, dalam bahasa Melayu, pengekstrakan logam daripada bijinya. Ore adalah biji. Okay, macam biji timah, we have to extract timah from biji timah. Begitu, contoh dia lah. Okay, so in this content standard, you're going to learn about you are going to explain extraction of metal from its ore through electrolysis process. Okay, macam mana logam itu diekstrak daripada bijinya dengan menggunakan proses electrolysis. So the electrolysis process will include this one, okay? Half equations at anode and cathode. This one you are familiar with it already. Redox reaction that occurs. Effects of extraction of aluminium from bauxite to the environment. So these are the description on extraction of aluminium specifically from bauxite. Okay. Learning standard number 2, you are going to explain metal extraction from its ore through reduction process by carbon. You have prior knowledge already about metal extraction from its ore using reactivity series in Form 3. So you are going to learn a little bit deeper in this subtopic, extraction of metal from its ore. Okay, let's go to your textbook. Okay, so here we are in your textbook, page 48. Extraction of metal from its ore, daripada bijinya. Pengekstrakan logam daripada bijinya. Okay, so extraction of metals, a little bit of introduction here. Look at the point number 1. Metals usually exist as compounds or mix with other substances. Ada logam wujud dalam bentuk sebatian ataupun bercampur dengan sebatian lain such as rocks and dirt. Okay, so compounds containing metals are also known as ore ataupun mineral and exist as metal oxides, metal sulfides or metal carbonate. These are the example of naturally occurring metal and ore. Ini naturally occurring metal, gold ataupun silver. Look at the second point here. Non-reactive metals, logam yang kurang reaktif, tidak reaktif, bukan lagi kurang, such as gold and silver, do not need to be extracted. Tidak payah sudah diekstrak. Extract means kasih keluar bah. No need to kasih keluar sudah because they exist as metal elements. Macam begini. This is gold. Memang di dalam kerak bumi pun memang beginilah rupanya. Reactive metals, logam yang reaktif like iron and aluminium require a particular way to be extracted from their respective ores. Okay, so ini adalah contoh iron ore. Okay, iron ore, biji ferrum ataupun biji besi. Kan, you always heard this one kan? Biji besi ataupun ini adalah biji aluminium. They have other name, okay? Diorang ada nama lain iaitu hematite and also bauxite. Bauxite adalah aluminium ore. Hematite adalah iron ore. So iron iaitu ferrum ataupun besi. Besi yang buat kereta, kita punya tingkap kan, besi-besi tingkap itu semua sebenarnya berasal dari ini, daripada ore, bijinya. Tidak akan wujud besi secara bersendirian macam gold. No, because besi ataupun Fe is more reactive than gold. And then aluminium also the same. This is the face of aluminium ore di dalam kerak bumi. Nama dia bauxite. So aluminium tu kan yang kita buat minuman tin. Contoh minuman tin. So minuman tin tu yang aluminium yang nipis tu bukanlah begitu di dalam kerak bumi. No, it exists this way as ore, sebagai biji. Okay, atau nama lainnya bauxite atau hematite. So there are actually the methods of extracting metals are based on the position of metals in the reactivity series of metal. Nah, I highlight this one for you. You need to hafal another reactivity series. Okay, you already hafal the SEPS kan, Standard Electrode Potential Series. Now you need to hafal another one, which is Reactivity Series of Metal. There are two common ways to extract metals from their respective ores. Nomor satu, we can use electrolysis for metals that are more reactive than carbon. Now, if you say more reactive than carbon, maksudnya apa? Maksudnya carbon tu is in the reactivity series yang kamu hafal tu. So, if you see yang more reactive than carbon, you use electrolysis lah. If you see yang less reactive than carbon, maksudnya di bawah carbon, we use reduction by carbon. Okay, so let us talk about the first method. Okay, cara yang pertama to extract metal from the ores. Cara yang pertama adalah electrolysis. Okay, extraction of metal from its ore through the process of electrolysis. Remember, we have two methods. One is electrolysis, two is reduction by carbon. Okay, so let us go to the notes over here. But before that, I would like to show you the one that you have learned when you were in Form 3. Okay, so this is the reactivity series of metal that you learned when you were in Form 3, okay? You have learned this one from your teacher when you were still in 3 Gemilang. So, let me remind you one more time. Ini adalah susunan-susunan logam mengikut kereaktifan. Look at the note over here. Kereaktifan logam terhadap oksigen bertambah. Maksudnya, makin naik, makin reaktif lah. Okay, how to hafal this one? This is my way. If your teacher already taught you her way or his way when you were in Form 3 and you still remember, yes, please remember it that way lah. Okay, kalau nak cantik, kalau is for kalium. Okay, I use kalau because K. Nak is for Na. Na for natrium. Cantik. Cantik is for Ca. Ca for calcium. We spell CAL in English kan. Kalau nak cantik, makan ayam. Makan is for magnesium, Mg. Ayam is for aluminium, Al. Zat ferrum. Zat is for zinc. Okay, obviously because of the Z. And then ferrum is ferrum, Fe, obviously. Supaya. Why are you supaya? Because the symbol for timah ataupun sternum is Sn. Okay. Supaya, Sn. Pasangan, plumbum. Okay, plumbum. Kekal, why I use kekal? Because of the K, cuprum. Okay, K, cuprum. So, you have to remember it that way lah. Di atas tu, cantik is for the Ca. Ca is the symbol for calcium. This one kekal. Kekal is for cuprum. So the symbol for cuprum is Cu. If you have your own acronym, please do so. Please remember it your way. No problem. Happy. Why I use happy? Because the symbol for mercury is Hg. Okay. And then always is for argentum. Anggun is for aurum. Why I use anggun? Because there's an A and there's a U here for aurum. Okay, so look at the reactivity series over here. Semakin ke atas, semakin reaktif. So, according to your textbook yang ini, we use electrolysis for metals that are more reactive than carbon. Look at the buku teks here. This one, Form 3 buku teks. In between, okay, this is Z kan. Di atas Z ada C. Okay, di bawah Z ada H. Remember that, okay? Zinc, atas dia ada carbon. Ada carbon, And then di bawah zinc ada hydrogen. So, look at the textbook here. For metals that are more reactive than carbon, we use electrolysis to extract it out. What are the metals that are more reactive than carbon according to the series are aluminium. Okay, look at this. Aluminium is more reactive sebab dia di atas carbon. Magnesium, calcium, natrium and kalium. Kalium is potassium lah in English, okay? So, look at this class. If you happen to see you use aluminium and magnesium, if you see this one di dalam kerak bumi yang sudah bercampur dengan dia punya bijinya, contohnya adalah bauxite, iaitu aluminium oxide ataupun aluminium ore, if you want to extract this one, keluarkan dia daripada bijinya, Nina, since dia di atas carbon, so apa cara yang kita guna adalah we use electrolysis. And we don't talk about this K, Na, Ca. You know why? Kalium bani, natrium bani, these are the reactive metal, super reactive metal from group 1. Takkanlah we want to use this one in electrolysis kan? Mustahil. Okay, so ingat for most of the example that you will see in your textbook or in your reference book, aluminium lah contoh yang paling digunakan untuk menceritakan tentang electrolysis. Electrolysis for apa? For metals yang mau dikeluarkan daripada dia punya biji. So extraction of metal from its ore for metals that are more reactive than carbon memang aluminium saja. Aluminium. Okay? So I hope you still remember this one. Okay, please remember, please hafal. And another thing is, Nina, reduction by carbon. This is a way ataupun cara that we use to extract metals from its ore because they are less reactive than carbon. Why less reactive? Because dia di bawah, see the carbon ba? Antara A dengan Z. Kalau saya lah, if I want to remember kan, I remember it that this way. A, B, C, D, F, Z. A dengan Z. A the first alphabet, Z the last alphabet kan. So di tengah-tengah diorang ada carbon. Because carbon ba kita punya cerita watak utama sekarang ni. Because of carbon, di atas ni guna electrolysis. Because of carbon, di bawah ni semua guna reduction. Okay, so apa contoh dia yang guna reduction adalah inilah zinc, ferrum. Look at the buku teks. The buku teks is going to tell you more about iron ore, hematite, iron ore. How iron ore are going to be extracted from the bijinya, from the ores. Okay, so this note is very important. I hope you can salin somewhere, okay, in your buku nota. Okay, so now we are going to talk about electrolysis. About what? About metals that are more reactive than carbon. So what is the metal that is more reactive than carbon? According to your series, is the aluminium. Look at your buku text. Here, this one is in page 48. Reactive metals like aluminium can be extracted from its ore using electrolysis. Kenapa begitu? Because aluminium di atas carbon. Okay? Is situated above carbon. In the extraction of aluminium ore ataupun we call it bauxite is firstly purified dulu to obtain aluminium oxide, which is then melted down. Mula-mula ditulinkan dulu and then dileburkan to enable the process of molten electrolysis to be conducted. Okay, so ini adalah dia punya proses lah, extraction of aluminium from molten aluminium oxide by electrolysis. This is the picture. So let us look at the picture dengan teliti di sini. This is carbon anode. Ada banyak If you see in Google, if you see in the di kilang lah, okay, skala yang lebih besar, actually bukan begini it's very super big, okay. Now, ini adalah contoh dia lah, carbon anode. Ada carbon anode, and then ada steel layer here. There are steel layer. There are carbon cathode di sekeliling ni tu negatively charged. Sekeliling dia ada carbon cathode. So this is not like our that we learn mula-mula. Begini kan, our electrolysis yang paling asas kan. We have electrolyte. Ini pun ada ba electrolyte? Inilah. Mixture of molten aluminium oxide. Okay? And also cryolite. Inilah. This is the electrolyte. Molten aluminium oxide. So why do we have to add this? Na3Al(F6) ini adalah cryolite. Okay, now you understand the picture already. They are anode adalah carbon anode, guna carbon because carbon is inert, lengai. And then we use carbon cathode juga di sekeliling. Okay, di sekeliling alat ini. Okay, so let us look at this one. The melting process uses extremely high energy since the melting point of aluminium is 2000 degrees Celsius. Aluminium ba ni yang we need to extract? Aluminium is a type of metal kan? Mestilah ba mau kasih lebur dia, mestilah mau pakai suhu yang sangat tinggi, 2000 no. So to overcome this problem, okay, overcome what problem? This problem. Because it uses extremely high energy, okay, tenaga haba yang sangat tinggi. Jadi akan berlaku penggunaan elektrik yang sangat banyak. So how to overcome this problem? Okay, kita guna cryolite. Cryolite is melted together with aluminium oxide. Kenapa mau kasih melt together? To lower its melting point. Okay, kasih turun dia punya melting point. Ingat aluminium oxide, aluminium bani yang we want to extract kan. So aluminium tu sangat tinggi. Dia punya takat lebur. Kasih turun sikit supaya jimat sikit elektrik dikilang. So we use what? We use cryolite. That's why the picture sini ada cryolite untuk kasih turun. Okay, to lower down the melting point for the molten aluminium oxide. Okay, I believe you still remember the basic principle for electrolysis ba. Electrolysis kan ada dua. Okay, we can talk about the electrolysis of molten electrolyte, or we also can talk about the aqueous electrolyte. Kan? Okay, contohnya, if aluminium oxide in aqueous form, how to what are the ions present here? I hope you still remember. Kalau aqueous solution, we have Al3+, we have O2-, we have H+, and also OH-. Kalau aqueous lah, kalau solution. But since this one is molten, this it's stated here it's molten, yang leburan. Jadi what are the ions present? Ada dua saja. One is Al3+, one is O2-. Okay, so senang cerita lah kan. Janganlah tengok yang ini. Okay, because we are going to talk about molten aluminium oxide. So di dalam molten aluminium oxide, we have aluminium ions and oxide ions. The extraction of aluminium using electrolysis is a redox reaction. Redox maksudnya mesti ada oxidation, mesti ada reduction. But what happens during the extraction? Okay, ini ceritanya. We have electrode for anode dan juga cathode. Ingat, the anode tu yang banyak tu okay? And then what are the reaction involved? Anode tu kan positif, kan kelas? Positif. And then cathode is negative. This one you understand already kan? For electrolysis. Electrolysis tu ada battery tu ada sumber tenaga elektrik. So, now mari kita tengok. Anode is positive masuk. Apa yang akan attracted? Which ions are going to be attracted? Of course lah, oxide ion. Kan? Because the negative will be attracted to the positive anode. So what happened? What happened in anode? Oxide ion, O2-, donates electron. Why donate? Sebab dia anode. Kan anode always donate. Okay, so the reaction, the half equation is going to be like this. Remember, when it donate already, bila dia adalah anode, dia terus anak panah like this. So, O2- donate electron to become oxygen gas lah bahkan. Kalau O2- mestilah jadi oxygen gas, right? Kalau Br- mestilah jadi Br2, right? Kalau Cl- mestilah jadi Cl2, begitu bah? Kan? And undergo oxidation reaction. Why oxidation reaction? Because dia derma electron, kan? And forms oxygen molecule. So, these are the reaction involved in anode. Okay, very easy. So, let us look at this one. Balance the chemical equation. There are two O here. Oxygen memang dua kan? So, you put 2 here lah. Because the O here bersendirian dua. This is the charge. Okay? So, 2 times 2 adalah negative 4. Kasih balance here, it will become 4 electron also. Itu di anode. So, which ion are going to be attracted to cathode? Yang negative is the aluminium lah. Aluminium ion is reduced to aluminium atom. Macam mana? By receiving electron and forms molten aluminium. Inilah ceritanya. In cathode, kan tadi tu oxide sudah menderma. Oxide already menderma, so Apa yang menerima? Cathode lah. Cathode tu ada apa? Ada aluminium lah, aluminium 3+. Kenapa Al3+? Sebab dia daripada molten. Molten, aluminium oxide, begitu. Okay, so Al3+ is going to accept 3 electrons. Kenapa 3? Because we want to balance the half equation. So we will have aluminium as liquid. Inilah yang kita mau. This is the molten. This is the molten aluminium that we want. Leburan aluminium. Inilah yang boleh buat kita punya tin cola, tin Pepsi, and so on. So that's what happened. Sini, molten aluminium flows out, akan mengalir keluar. Okay, jadi daripada konsep electrolysis itu dan juga reactivity series of metal, you now understand that aluminium can be extracted from its ore by electrolysis. Kenapa? Sebab dia di atas carbon. Okay, so let us look at this one. The point here, molten aluminium sinks to the bottom of the layer because its density is higher. Then it drain out through a designated channel. Ni nalah molten aluminium flows out. Barulah dia akan pergi kepada channel yang sudah kena design. The entire process of aluminium extraction consume a huge amount of electricity. Ingat tu because of what? Because of dia punya takad lebur tinggi ba? 2000 degrees Celsius. During the process of electrolysis for molten aluminium oxide, carbon dioxide is also formed, which negatively affects the environment. Tahu kan apa kesan carbon dioxide? Pemanasan global. Kalau kita membakar pun, we will release the carbon dioxide daripada pembakaran terbuka. Contoh, okay. So from this process, electrolysis of molten aluminium oxide pun sama juga menyebabkan pencemaran alam sekitar, which is global warming. Kenapa? Because ada carbon dioxide. So apart from that, the purification process of bauxite also creates a residue in the form of red sludge that is toxic. You see, remember, before you want to take the bauxite untuk kasih electrolysis dia, kita perlu purify dulu. So masa penulinan tu ada red sludge, toxic. Look at the news over here. Red toxic sludge pollution from bauxite waste, daripada sisa-sisa bauxite, due to a burst reservoir in Hungary in 2010. So ini kesan pada pencemaran pada alam sekitar. Okay. Therefore, as consumers, we must recycle aluminium to reduce pollution to the environment. Kan? So it is better. Okay, there's one point here that attracted me. This one. Aluminium is a common mineral found in Earth's crust. Memang common. Memang adalah yang biasa ditemui. Okay, mineral ataupun biji yang biasa ditemui dalam kerak bumi. However, recycling aluminium is 95% better, more efficient compared to extracting aluminium from bauxite. I hope you understand sudahlah kenapa recycling adalah lebih baik. Recycling apa? Recycling aluminium. Kenapa lebih baik? Because punya banyak dia punya kesan ni, kan? Red sludge lah, lepas tu apa lagi? Ada carbon dioxide lah, kan? And then sudahlah dia, it consume high amount of electricity. So there are a lot of side effects kalau mau extract aluminium. So better recycle. Better recycle. So as a pupil, kamu sebagai seorang murid, what is the role that you can play in this issue? If you ask me, mestilah bakal si kemek the tin, kan? Tin, minuman tin. Itu. So that's what you can do. Save the environment. We don't want red toxic sludge. We don't want carbon dioxide. Okay, from the extraction. Okay, so you need to watch this video in this page 49, extraction of aluminium metal, and I will also attach this one in our Google Classroom. Okay, so let us go to the next process, extraction of metal from its ore through the process of carbon reduction. So remember, there are two ways to extract metal. One, if the metal are above carbon, we use electrolysis. Apa contoh? Aluminium. I already explained. So the next thing that you're going to learn is this one. Okay? You are going to learn about carbon reduction. We will use carbon to reduce the metals yang di bawah dia. Okay, supaya itu metal boleh di-extract. Okay, so what happened in the extraction of metal through the process of carbon reduction? Remember, in your science textbook, Form 3 already mentioned that all the metals below carbon can be extracted by using carbon reduction. So that's what we are going to learn. And in your Form 5 textbook, the one that's being emphasized, yang ditekankan adalah iron metal. Iron metal, which is less reactive than carbon, can be extracted by carbon through reduction process. Okay, let us look at di mana kedudukan dia di bawah carbon. Ni nih, di bawah carbon. Ferrum di bawah carbon. So we use reduction, penurunan. So the process is carried out in a blast furnace atau in bahasa Melayu, relau bagas. By heating up iron ore, memanaskan iron ore, okay, biji besi atau hematite with coke and limestone. Okay, apa yang penting di sini adalah you need to remember a few things such as what is the function of calcium carbonate, what is the function of coke, begitu. Okay, so this is the blast furnace dalam buku teks lah, but in real life it looks like this. It's a super big like machine di dalam kilang lah, okay, dalam industri. So what happened? Iron ore, biji besi, kan we want to extract the iron out. So we panaskan, we heat iron ore, coke ataupun arang batu, and also calcium carbonate di dalam relau bagas ini. So there are waste gas yang akan dibebaskan lah. There are 3 zone. Zone 3, zone 2, and zone 1. Okay, yang ini adalah hot air masuk ke dalam. And then what we want in this process adalah this one, molten iron. Di atas leburan besi itu ada this one, slag. You know slag dalam bahasa Melayu, it's called sanga. Okay, yang bikin buat jalan raya, turap jalan raya, itulah. Okay, so let us look at what happened in zone 1 first. Ini di bawah. So in zone 1, coke reacts with oxygen from the hot air to form carbon dioxide. You see this picture here? There are hot air coming in the zone 1. So the hot air, which is ada oksigen lah di dalam kan, udara yang panas, akan bertindak balas dengan carbon. Okay, carbon tu apa? Coke, arang batu, carbon lah tu, to form carbon dioxide. Itu dalam step 1. This is a redox exothermic reaction. Remember, exothermic means dia membebaskan haba. That makes the temperature of the blast furnace reach 1600 degrees Celsius. Because dia terbakar, okay? Panaskan carbon together with the oxygen. Oxygen dari mana? Dari hot air. Okay, itu zone 1. Zone 2, atas sikit, what happened? The produced carbon dioxide, Nina, from zone 1, the produced carbon dioxide reacts with the remaining coal. Okay, kita ada carbon dioxide dari zone 1 kan? It will react with the remaining coal dengan arang batu yang selebihnya. So, kita akan dapat carbon monoxide. So, carbon monoxide is the reducing agent for the subsequent reaction. Ini adalah agen penurunan lah sebab dia mengalami pengoksidaan. This is an endothermic reaction that lowers the temperature in zone 2. So zone 1 exothermic, panas lah because ada hot air. Zone 2 endothermic, untuk turunkan sikit, tidak mau 1600, nanti mahal bayaran bill, begitulah. Okay, zone 3. So what happened here in zone 3? Coke and carbon monoxide function as reducing agent and reduce iron 3 oxide or iron ore to molten ore. So there are two things here. Satu adalah carbon ataupun coke. Coke yang mula-mula kita kasih masuk from here. Okay, the coke and also the carbon monoxide from the step number 2. Those two are going to react with the ore. Apa ore? Biji besi ataupun hematite ataupun iron trioxide, because we want to have this iron ma. So after we have the coke and also carbon monoxide react with this iron trioxide, we will have our molten ferrum ataupun molten besi di bawah sinilah. We will have this molten iron. Okay, so iron trioxide is reduced by carbon monoxide. Iron deposit are formed at the bottom of the blast furnace. Ingat we have the coke daripada awal-awal lagi here, and we have the carbon monoxide from the second zone react with our ore to produce ini. Banyak kegunaan ni besi, kan? Buat kereta pun boleh. At high temperature, calcium carbonate, kan? There's another thing that you need to understand. Okay, just now you already understand what is the function of this coke. Kan coke tu adalah boleh bertindak balas dengan iron ore. Why? So that the iron ore can produce Fe. Like that. So what is the function of this one? Calcium carbonate. Mesti ada fungsi dia. So let us look at this one. At high temperature, calcium carbonate decomposes. Ni na, CaCO3 solid is terurai, decomposes at high temperature to form calcium oxide, quicklime, and also carbon dioxide. So apa yang terjadi? Impurities in the iron ore, like silicon 4 oxide SiO2, ada bahan-bahan ataupun residue. Impurities maksudnya kita yang tidak mau. Okay, impurities, bahan yang kita tidak mau impurities akan terhasil in the iron ore, akan terhasil seperti SiO2. Dalam iron ore ada impurities, benda asing. Kita tidak mau ni, bahan yang kita tidak mau dalam iron ore. Okay, so what happened with the SiO2 impurities tu? It's going to react with calcium oxide. Dari mana calcium oxide? Dari sini, from the decomposition of calcium carbonate. It's going to react with calcium oxide to form slag, untuk membentuk sanga, ataupun calcium silicate, CaSiO3. Nah, jadi di sinilah fungsi dia tu. Can you see the function of the CaCO3 now? Okay, calcium carbonate is going to be decomposed, akan diuraikan at high temperature. Kenapa? To form the CaO. Okay? And then, CaO ni buat apa? Calcium oxide ni buat apa? It's going to react with the impurities. Di dalam iron ore, di dalam biji besi yang kita mau extract tu, ada benda asing. So, the calcium oxide is going to react with that impurities to form sanga ataupun slag in English. Okay, ini ada explanation dia di sini dengan lebih lanjut lagi. Calcium oxide, CaO, is a base. So, base ni, this one, is going to neutralize the acidic silicon 4 oxide. Jadi, di sanalah fungsi dia. It's going to neutralize the impurities. This reaction is important to separate the impurities from molten iron. The difference in density, okay, perbezaan daripada aspek density ataupun ketumpatan causes the slag to be at the top layer, which makes the separation process easier. Maksudnya begini, okay, bila kamu habis sudah, okay, the blast furnace habis sudah dia punya proses, so what you will see is ada slag di atas. Slag tu dari mana? Slag tu adalah CaSiO3, okay, calcium silicate. So calcium silicate tu dari mana? Calcium silicate tu daripada impurities, benda asing di dalam kamu punya iron ore. So macam mana mau kasih hilang tu? Kita guna calcium carbonate. Panaskan calcium carbonate, dapatkan CaO. So tindak balaskan CaO with the silicon dioxide. Okay? From the impurities. Jadi dia akan neutralize lah di sana. And it's going to form slag. Slag kurang tumpat. Slag di atas. Molten iron di bawah. So this is the one yang kita mau. Okay, ini sanga. Sanga untuk buat jalan raya. Penurapan jalan raya. Molten iron banyak kegunaan. Besi bani sangat banyak kegunaan. Just look around you. There are too many things that are made from iron. So I hope you understand what happened in zone 1, zone 2 and zone 3. What are the function of the coke and also calcium carbonate. Okay? So there's one more method to extract metal. Okay? Ada lagi satu cara untuk macam mana mau extract metal. Kamu sudah belajar dua cara. Satu, look at this textbook again. Page 48. Coba tengok yang ini. Okay, the first method untuk extract metals adalah by using electrolysis. And electrolysis can only be done by a reactive metal yang lebih reaktif daripada carbon. Remember, kita punya series, reactivity series. Ingat, if the metals are above the carbon, so we use electrolysis, kan? And then if the metals are all below the carbon, we use reduction. So there's another way sebenarnya untuk extract metal, which is by using a more reactive metal. Dan ini sebenarnya adalah ilmu yang kamu sudah belajar, yaitu tentang reduction. Okay, about the reduction. So when metals are heated together, bila metals logam dipanaskan bersama, the more reactive metal can extract the less reactive metal from its metal oxide. Okay, apa maksudnya? Begini. Ini aluminium. Ini iron 2 oxide. Okay, let us look at the reactivity series here. Aluminium berada di atas ferrum, kan? Okay, aluminium is located above the iron in the reactivity series of metal. So, apa maksudnya di sentence? The more reactive metal can extract the less reactive metal. Maksudnya begini. Look at this aluminium here. It reacts with the iron 2 oxide, right? Okay? And then what happened after that is, cuba kamu tengok. This aluminium kan, dia ambil the oxide bah. So maksudnya di sana, the aluminium is going to combine with the oxide from the metal oxide yang perlu di-extract. Jadi akhirnya, you are going to have the iron that you want. So this is how you extract metal. Macam mana mau pisahkan, macam mana mau extract iron from its iron ore. This one we call it iron ore kan. Okay, iron 3 oxide. How to pisahkan iron 3 oxide? How to pisahkan iron from iron 3 oxide is, we just need to heat these two together. Metal and metal oxide. Syarat dia, okay, the condition is metal that you panaskan together, it must be a higher located metal in the reactivity series. Kalau dia di bawah, cannot. Dia mesti di atas only. Okay, let us look at the points again. For example, in a termite reaction, aluminium powder is heated together with iron 3 oxide. Nah, ni aluminium dipanaskan bersama-sama dengan iron 3 oxide powder. Okay, termite. Apa maksud termite? Termite maksudnya you want to produce extraction of metal. Okay, you have to watch this one. Termite reaction. Ada guna dia tu. Apa kegunaan itu termite? We look at the point first. The more reactive aluminium ini, as I have told you just now, reduces iron 3 oxide to produce molten iron. This is a very useful reaction in producing small quantities of molten iron for welding railway tracks. Okay, so that's what termite reaction for. Okay, kita mau daripada termite reaction ni kita mau hasilkan kuantiti leburan sikit sajalah, kuantiti yang sedikit, leburan besi. Leburan besi itu apa kegunaan dia? Contoh adalah welding railway tracks. Railway tracks, you know kan? landasan kereta api. Welding tu apa? Welding is to join pieces of metal by pressure, often by using heat, electricity, etc. Okay, jadi welding tu adalah kita mau combine dua jenis metal together. Dalam bahasa Melayu, mengimpal, kimpalan. I believe you have heard this one lah. Okay, so termite reaction sebenarnya adalah contoh how to extract less reactive metal by using a more reactive metal. Okay, let us look at the point again. Some other metals like chromium, titanium can be extracted from their respective metal oxides using reduction by more reactive metal. Chromium, titanium boleh diekstrak dengan menggunakan logam yang lebih reaktif. So let us look at the reactivity series of metal. This one is more or less the same like your Form 3 textbook. Okay, so kalau nak cantik, it's different. Kalau nak cantik, it's different from your Form 3 textbook. So look at the position over here. Look at the series here. Potassium, sodium, magnesium, aluminium. Potassium, sodium, magnesium, aluminium is located above carbon. So the best way to extract the metal is by using electrolysis. Remember, kalau di atas carbon, all of the metal we use electrolysis because they are very reactive. Okay, kalau di bawah, moderately reactive metals from zinc, iron, stannum, plumbum. So this moderately reactive metal, the best way to extract the metal from its ore by reduction is by reduction of carbon. Okay, you kasih tindak balas this one with carbon. So dia punya persamaan akan jadi begini. Contoh, zinc. Contohnya, zinc, you want to extract zinc from its oxide. So means zinc oxide lah. Zinc oxide, you react with carbon. So what will happen after this? Are you going to see zinc again combined with the ore? Tidak kan? Sebab dia sudah di-reduce. So what happen after the reduction? Reduction by carbon adalah you will have zinc and then you will have carbon dioxide. Begitulah. Okay, because the C ambil itu ore sudah bah. That's why we say ini akan jadi, this one will be reducing agent. Carbon is the reducing agent because dia reduce ni na ba. Okay, so zinc akan kena extract. So for less reactive metal, metal is extracted from its ore by direct heating in air. Panas saja secara terus. Okay, terus di udara. Contoh, copper and also mercury. Unreactive metal macam mana? Unreactive, tidak reaktif. It exists as element. Tidak payah susah-susah buat semua di atas. Argentum and aurum, silver and gold, both are unreactive metal. So you can just take it if you saw it di dalam kerak bumi. Okay? So you please do the self-assess 1.5. I hope you learn a lot from this subtopic 1.5.